Good day, viewers. Now let's provide solution to this trig identities problem on the board. Now we are given if 2 tan alpha equals to 3 tan beta. Now we want to show that tan of the difference between alpha and beta is equals to sine 2 beta over 5 minus cos 2 beta. Okay, now let's have our solution. So we are given 2 tan alpha equals to 3 tan beta. Okay, and we want to show that we want to prove that tan of the difference between alpha and beta is equals to sine 2 beta over 5 minus cos 2 beta. Now let's express tan alpha in terms of tan beta. That will be step number 1. So step 1, express tan alpha, okay, in terms of tan beta. Okay, so we are given 2 tan alpha equals to 3 tan beta. So let's express tan alpha in terms of tan beta. So to do that, because we are given 2 tan alpha equals to 3 tan beta, so let's divide both sides by 2. Now we're going to have 2 tan alpha divided by 2 equals to 3 over 2 tan beta. All right, this will be taken care of. So then we'll be left with tan alpha equals to 3 over 2 tan beta. So this is the equation connecting tan alpha and what? Tan beta. Okay, so with this, now let's also remember that we can use this we can substitute this for tan alpha when we expand, if we expand this identity, there's an identity for tan of the difference between two angles. Now let's recall. Now step 2. Now using the identity tan, okay, of the difference between alpha and beta, which is tan alpha minus tan beta over 1 plus tan alpha multiplied by what? Tan beta. When this is negative, okay, the sign here will be what? Positive. And that's because this is what? Tan of the difference between the two angles, okay? But when it is sum, then this will be what? This will be sum. This will be plus. And why this will be what? Minus, okay? All right, so we are now going to substitute what we have here for tan alpha. We are going to substitute it into this. We are going to substitute 3 over 2 tan beta for tan alpha in this equation. All right, so we have tan alpha minus beta. So tan alpha is now 3 over 2 tan beta, then minus tan beta all over 1 plus, then again tan alpha is what? 3 over 2. Okay, then we have tan beta, then multiply by tan beta. That will be tan square beta. Okay, because tan beta multiplied by tan beta will be what? Tan square beta. Now let's simplify this, the right hand side. Remember, we are using the right hand side to prove why the left hand side, okay, in this is equals to sine 2 beta over 5 minus cos 2 beta. All right, so that means to be able to simplify this, we'll need to multiply the top and the bottom by 2. Okay, now multiplying the top, or let's say multiply the top, and the bottom by 2. So the top is 3 over 2, okay, tan beta, okay, multiply by 2, then minus tan beta, okay, multiply by 2 all over, this will be 1 times 2 plus 2 multiply by 3 over 2, then tan square beta. Okay, all right, so let's not forget that. Okay, so this will cancel out. Okay, so this will reduce to 3 tan beta. Okay, that is because 2 divided by 2 is 1. So 3 tan beta minus, this will now become 2 tan beta all over 2 times 1, that's 2, plus this will also cancel out. Then this will be 3 tan square beta. Now we know that 3 tan beta minus 2 tan beta will be beta. So this becomes, now note, we know that 3 tan beta minus 2 tan beta is what? Is 1 tan beta. Rather, it will be 1 tan beta. That is 3 minus 2, that's 1. So this is common. So, okay. So that means the numerator will now reduce to tan beta all over 2 plus 3 tan square beta. Now remember, the left hand side is what? Tan alpha minus beta. That's the tan of the difference between alpha and beta. Okay, but this is what? This is the right hand side. So we want to use the right hand side, okay, to what? To prove that the left hand side is equals to this identity. Now also let's not forget that tan beta can be what? Can be expressed as sine beta over cos beta. So which means we know that tan beta is sine beta over cos beta. Okay, so which means if we put that in this expression, we're going to have sine beta over cos beta. Okay, all over 2 plus, now this becomes sine beta over cos beta. Okay, raised to the power of 2. So let's multiply the top and the bottom by what? By cos beta. Let's multiply the top and the bottom by cos square beta. Okay, now, so in this case, so from here, multiply the top and the bottom by cos square beta. Yeah, cos square beta. Remember, we multiply the top and the bottom by 2 in this case, and we have the expression to reduce to tan beta over 2 plus 3 tan square beta. And because we know that tan beta is equals to sine beta over cos beta, so we can rewrite tan beta in this case as sine beta over cos beta all over 2 plus 3 bracket sine beta over cos beta, which is same as tan beta, then raise it to the power of 2. So when we multiply the numerator and denominator by cos square beta, so we are going to have a new expression. So we are going to multiply, remember, we're still dealing with the right hand side. So, and that will be sine beta over cos beta multiplied by cos square beta all over, this will be 2 cos square beta, okay, then plus, now of course, this will be sine square beta over cos square beta. So this will reduce to 3 sine squared beta. Okay, so when this cancel out, so we'll be left with what? Cos beta. So the new expression will become sine beta cos beta all over 2 cos square beta plus 3 sine square beta. So step 3, okay, multiply the numerator, okay, and denominator by 2. So when this is multiplied by 2, so that will be 2 multiplied by sine beta cos beta over 2 multiplied by cos square beta. Okay, this will be 2 multiplied by 2 cos square beta plus 2 multiplied by 3 sine squared beta. So this will be now 2 sine beta cos beta is the same as sine 2 beta. So that will be, this will be sine 2 beta, okay, and this will be 4 cos squared beta plus 6, okay, sine squared beta. Okay, so now this is because when we multiply sine beta cos beta by 2, we are going to have the double angle identity for sine. You know, sine 2 beta will be 2 sine beta cos beta, and that's what we have there. So now I'm also going to expand this. I'm going to expand the denominator. You know, this is what we have. We have sine beta over 4 cos squared beta plus 6 sine squared beta is sine 2 beta all over. So this will be 4 cos squared beta plus, now I said I'm going to expand in this case. Now because I know that I can also take out, you know, I can write this, I can expand this to be 4 sine squared beta plus 2 sine squared beta, which is same thing as 6 sine squared beta. So this will be 4 sine squared beta plus 2 sine squared beta. Okay, let me write that. Okay, so what I've done here is that I expanded this. This becomes 4 sine squared beta plus 2 sine squared beta. Okay, now, so we have what looks like the one of the Pythagorean identity in this case, which is if I factor out 4 from 4 cos squared beta plus 4 sine squared beta. Okay, we're going to have cos squared beta plus sine squared beta, which is one of the Pythagorean identity. So for that, we're going to have sine 2 beta over 4 parentheses cos squared beta plus sine squared beta plus 2 sine squared beta. Can we see that? So now we know that cos squared beta plus sine squared beta is what? 1. Now we know that, let me write it here. We know that cos squared beta plus sine squared beta is equals to 1. I'm still going to write one more here. So this now reduced to, this will be 1. So this becomes sine 2 beta over this becomes 1. So this will be 4 plus 2 sine squared beta. 2 sine squared beta. Okay. Cos 2 beta. Cos 2 beta is equals to 1 minus 2 sine squared beta. Okay, that's the double angle identity for cosine. So cos 2 beta equals to 1 minus 2 sine squared beta. So we have sine 2 beta over 4 plus, now we have 2 sine squared beta. Okay, now if we bring this to the left hand side and we move this to the right hand side, in this case this becomes cos 2 beta. Okay, so this will be so sine 2 sine squared beta. Okay, from here we have 2 sine squared beta will be equals to 1 minus cos 2 beta. Yes, because I use 5 minus 1, okay, and I was able to do some, you know, I did some manipulations here and I was able to get this, but we can still maintain this. Okay, so we have sine 2 beta over 4 plus, so 2 sine squared beta will be equals to 1 minus cos 2 beta, and that will be, this will be 1 minus cos 2 beta. Don't forget, this is the right hand side. The left hand side is what? Tan alpha minus beta. So this becomes, so we then have sine 2 beta over 4 plus 1 is 5. So we have 5 cos 2 beta. So we can say therefore the right hand side is equivalent to the what? The left hand side. Let's not forget that the left hand side is tan of the difference between alpha and what? Beta. So, and we can then say that tan alpha minus beta is equals to sine 2 beta over 5 minus cos 2 beta. So we just prove that the left hand side is equivalent to the what? To the right hand side. So, and we know that the left hand side is tan alpha minus beta equals to sine 2 beta over 5 minus cos 2 beta. beta. And that we just come to the end of this session. The noblest pleasure is the joy of understanding. Bye bye.